This is a CLM 1000 hydraulic shifting valve, specially designed for Centerline Manufacturing. It changes the direction of flow through these two ports while allowing in and out to continue on the two ports on the opposite side. This is what shifts the direction of the hydraulic cylinder, which controls the mud pump. We start off building this by lightly sanding the grind marks that foundry leaves on top of it to smooth them out. Always wear safety glasses when doing so. You've got some of the groove smoothed out, it leaves a sharp edge right here if you just smooth that sharp edge out. Awesome. After you've got that sanded, you will then need to check the inside for burrs, especially in the top port on the number 16 inside and on the lower port number 16. On the edges here there will be burrs of material often that need to be drug out with a pick. This one isn't bad, but the lower port is usually got pretty good chunks. There's a chunk there. Just break them off with a pick. We're going to flush the valve out before we assemble it anyway. Here's a pretty good example. I always check the other ports on the other side, but there's usually nothing there. But I check them for safety's sake. Okay, once you've completed that, look down the spools, the spool bores, and you can see there are lands, spaces in which the bore is missing, and that's for oil flows. There is a chamfer on the edge of these lands. Sometimes there's not a good enough chamfer and there's a burr there. If it is not, you'll have to deburr that using a cogsdale. And these seem to be good. They were done well enough. After you've done that, go ahead and turn the valve up on end, hang it off the edge of the table and clamp it to the table. I use a piece of aluminum just to keep from clamping directly on the valve and damaging it. You want to hang one of the bores off. It doesn't really matter which bore you start with, but I'll start with a big one just because. Kind of clean a little bit, flush everything out. Take one of the spools that goes in it, like this. There are two different lengths of these spools around. It will be the shorter length. The longer spool is for the old style valves that we no longer use. Clean that spool off, put a little WD-40 on it, and check for fitment. fairly tight. It's tighter than it needs to be, so we're going to have to hone this. I use a brass punch and knock it back out lightly with it so I don't damage anything. This is the hone they use in the machine when they manufacture the valve originally. Sometimes they don't quite get enough out and the spools won't fit. It's a diamond face hone, so be very careful. It's very expensive. It has a slight U-joint to it with some wobble to kind of take out any play in it. There's an adapter we made to stick in the drill trap. We keep it over here by the table. When you hone these, you'll turn the chuck down a little bit on the drill, so if it does get in a bind, it doesn't jerk or damage anything. It just clicks and the clutch releases. Put some lubricant on the hone. Put it in there. Now be aware that the hone is not straight. The sides are not parallel. They're tapered. They taper out toward the center and then taper back in. The center is the largest point of the hone itself. You can tell where it begins to bind at by the load on the drill. Once this bore you've got the spool going through the bore, once you've honed a little bit, take clean spool, place a WD-40 on it, check the fit. Once you've got it fitting freely, it needs to move freely. A small amount of drag is okay, but you don't want much, not much at all. You want freedom of movement on it though. That is the proper fit. Once you've got that, set the spool aside and turn your valve around to where the other bore is hanging off of the table. It's got some trash in it, so you want to make sure the bore is clean before you try spooling it, so that if it's hanging, it's not because of a piece of trash in there hanging. Take your spool. Try it. And that's good. That's the way it should fit. No need to hone this one. From this point, I have a bucket of coolant readily available in which to flush the valve with to make sure any trash or any fine particles of material are removed from it. I flip it different directions and in and out. The fluid seems to work pretty well. Shake most of the coolant out of it. Then I go from there to this little platform here. On this platform I remove the coolant. everything from inside it. Make sure it's one final cleaning before assembly. Valve should be clean now. Using it. Now we begin the actual assembly of the valve. I usually begin by installing the upper valve spool. Roughly 1 inch in OD. I clean it yet again. WD-40. Insert. We have these plugs they manufacture. They don't come with an O-ring on them. You have to put that on there. I've just done it for the video. Always oil an O-ring before I assemble it because rubber is a porous surface and it helps the O-ring go in without any galling or cutting or anything. That one doesn't want to thread it.
Fine, get out of there first.
Spools in. I use a small impact. Never use a large impact. These don't produce the power that those do. You won't damage anything with a small impact. Now the upper spool is installed. It matters not which direction you place the upper spool in. The lower spool, however, does matter. When you look at the valve with both number 16 ports pointing out at you, this is the end that will connect to the slide, and this is the end that will have the detent. So the spool must go on with the flats on this end. So, clean the spool again. Lubricate it. Install it into the valve. I usually begin with the backside for no particular reason. Now you have the seals, the polypacks. There is a side with an O-ring on it inset, and there's a side without. The O-ring side faces in the valve like so. And if you look at it edgewise, you can see that it's slightly larger on that side. It has a lip to it. You cannot just force that into the valve. If you do so, the O-ring will pop out and the seal will not seat properly. So lubricate the seal, slide it on. Using 2 picks, use one pick to roll the lip down and the other pick to press the lip in, and just working it away around it like so. You can get the seal in there. Once you've got the lip all the way in on the back side, you can just press it in the rest of the way. It's in. On top of that, you have a wiper. This is called a hard wiper because it's not rubbery. It's made of a hard material. And these are what we prefer. If you end up with a rubbery wiper, you've got the wrong product. This goes on top of that. The wiper wipes the shaft as it goes back and forth and prevents any debris and such from getting to the seal. On top of that, you have a little flat washer. There are 2 types. There is an unmachined one and a machined one. There's not much taken off of this. It's almost exactly the same thickness as the other one. It's maybe 5 thousandths thinner. And the idea is that the sides are parallel so that the block is parallel to the face. This is a detent block. It will contain balls and springs on each side, which will go on, click into these grooves on the detent roller. The bores inside, which actually intersect the large bore here, not the threads, but just a small bore through there, are hardened. They're carburized to create a harder finish so they do not wear out. On the detent roller, I usually put on next. And it, due to the heat treat process, it has some crummy stuff on it. So I usually clean those with a wire brush and back. A detent roller is made of 8620, which once heat treated becomes a very, very hard material. The tolerance between the block and the detent roller is very tight. Hence the reason you don't want to leave any of that stuff, the coating left from the heat treat on it. It's mostly just carbon that has come out of the material. There's a 3/8 24 inch and 3/4 long bolt that goes inside the detent roller. Just place it in there. Put a little Loctite on the threads of the bolt. Thread it into the back of the spool. Using a 5/8 wrench, hold the flat of the spool, and taking an impact with a 9/16 socket, which I thought I had that one right here. Again, not a large impact, entirely too much torque for this. And tighten that down. Now you're ready for the detent block itself. I have already cleaned this one, but it also is coated with a lot of carbon from the heat treat process, and the threads are usually quite coated. They need to be cleaned thoroughly before assembly. And it fits, as you can see, very tightly over the roller. It's not a lot of play there. Because of this, you have to ensure that you get it tightened down very flat. There's 4 5/16 by 24 bolts, and put a lock washer on them. Go around here. Sometimes the bolts don't want to fit through the holes because the holes are fairly tight with the bolts. There would be a very slight burr. Take a deburr knife and do all 4 of the holes on both sides, and they should fit right through. Oh. Again, Loctite the bolts. We're using blue 242 Loctite. It's a medium strength. Now again, it's a very tight fit between that roller and this block. And being that there's some small amount of play in the bolt holes, though not much, in order to ensure that we get a good equal tension on each bolt, I use a torque wrench to tighten them down. I start at 10 foot-pounds. You want to roll the spool around a little bit to kind of help center that block around that spool, and you want to continue rolling the spool as you tighten it. Even after you fully tighten it, you may end up with a little bit of a tight spot in the end, and that's okay. It'll still function just fine. This one seems to be better than most, so I don't feel any tight spots in it. I always go back and verify that you reach full torque on the first two. First torque, let's ensure that it's still spinning freely. And it is. Then I got a 20 foot-pound, and that's where I stop. Always set the torque wrench back to 0. And we'll check, and it still spins freely. That's what we want right there. Now we will install the actual detent parts. Or the steel ball bearing fits inside the hole. Bottom of there. Take this number 8 JIC plug, place the springs in it, get it over the hole. Just get it started. Same thing on the other side. Place the ball up in the hole. You got to get it to catch. Some Loctite on the threads. Run them in the rest of the way. This is what applies tension to your ball bearings to create the actual detent. And then take again the small impact. Tighten those up. And now you can see the detent. It's oily, I can't grab it. Actually clicks back and forth and creates a full range of motion. It forces the valve to make a full shift. Now we take a grease zerk and put it on top. Detent. Tighten it down. And the detent side is done. Now you can turn the valve back around. Pause it. The other side's the same as this side with the seal. It goes the same direction, you have to work it in. Lubricate the seal. Slide it over the shaft. Do it up to there. Take your 2 picks here. Apply a light pressure here and work that lip in. And again, you get a hard wiper that goes on top of it. And you have these to this side. I clean every part for no other reason than just so it's clean. And it's assembled. This goes here. Well, before we put that on, there are these plugs. Normally put those plugs in first, because if you wait until after and you put this on, it covers a portion of the plug and you cannot install it. The plug is already in the other side. I didn't video that. Let's spray some WD-40 on them, get them started, and run them in. There's 4 of them, 1 on each end and 2 on the side. There are also 4 small plugs. These may appear to be number 4, but they are not. They are number 3. So do not order number 4 plugs expecting them to fit. They are a touch smaller. And normally, so far we have WD-40 every O-ring, but with these small plugs on the bottom, due to the nature of where they are at, being mounted on the bottom side of the valve, when the valve is mounted on the plate, if there happens to be a slight leak on these, it's a lot of difficulty to repair. So, because of that, I Loctite these with 545 hydraulic thread sealant. I just place a little on the O-ring. And they're an 1/8 inch wrench to run them in. Being 1/8 inch, obviously you can't get a whole lot of torque on it really. But don't think to get a bigger one. I've gotten some with a bigger Allen in them. And having a bigger Allen, it places the opening where the Allen is closer to the edge of the material, and it will actually blow out and crack off. You have to use Allen plugs. You cannot use hex plugs because they do not fit everywhere they need to go. is this. The top one's a WD-40 because they're easily accessible. Alright, now place this cover over it. To install that, we use socket head cap screws. They're 5/16 24, just like the bolts on the other side. I like to do it. A little on each one, then roll it around. I get a good even coating. I'm going to start each one. Run in just a little bit. Now, the valve is assembled. Plug off all the holes, all the ports. Next step, take the valve back, cleaning spot, and using brake cleaner. Clean the whole exterior of the valve to remove any excess oils or Loctites or anything that might be on the exterior of the valve. Blow it dry. Look it over to ensure you haven't missed any oil or Loctite on it. Now the valve is ready for paint.